We're now at part B of question 8 from the January 2021 CSEC Mathematics past paper. Right? Now, it says the function f and g are defined as follows. F of x is mapped onto 5 minus x, and g of x is mapped onto x squared minus 2x minus 1. The graph of f of x and g of x meet at the point m and n. Okay. Determine the coordinates of the points m and n. Alright, I copied this over here already. Just looking at the point, how many marks? 4 marks. Okay. Now, let's look at it. Remember now, what you have here, as you can see, will be 2 lines. F of x is a straight line, and g of x is a, you tell me, it will be a curve, but what's the name of that curve? It's going to be a parabola, because it is a graph of a quadratic equation. Alright? F of x is a linear equation. It's a straight line that you will get. And g of x is a graph of a quadratic equation, and that particular curve that you will get is called a parabola. From looking at it, what will be the shape? Will this curve have a maximum or a minimum point? It will be a minimum point. Right? G of x will be like this because the number that multiplies x squared is positive. Alright? As for f of x, does it have a positive or a negative gradient? It's a negative gradient because the number that multiplies x is negative. Remember, the general form of a straight line is y is equal to mx plus c. When m is positive, you have the line going up. When you go from upper left to lower right, you'll be rising. And if m is negative, when you go from upper left to lower right on the line, you'll be going down. Right? Negative gradient. But anyway, let's say this is our arrangement here. What you're going to have to do is this. Alright, first of all, I want you to pause the video, figure out how you're going to get this and work it out for me. Alright, you pause the video and you work it out. How did you do it and what did you get? Anyway, let's look at this. When this happens, when they meet, then the functions are equal to each other at that point when they meet. X squared minus 2x minus 1 is equal to 5 minus x. That's what happened. Alright? You're not going to be plotting and drawing the curves. Right? You do it by calculation here. You could do it by plotting and drawing the curve, but that will take too long. Right? Once you know to do it by calculation, you do it quickly. Although I myself, I'm not in exam right now, so I'm not going to be doing it quickly. Here, if you subtract 5 from both sides and add x to both sides, what will happen? It's x squared minus 2x minus 1 minus 5 on the left. On the right, when you minus 5, it will disappear. 5 minus 5 is 0. You add x on the left of the equal sign. When you add x over here, negative x plus x is 0. What you have is all of this is 0. And remember, I'm rewriting this to make it into the general form of the quadratic equation. When you look at your formula sheet, you will see the quadratic equation, the general form of it, and you also see the quadratic formula that you can use. Alright. So you have x squared minus 2x plus x will be minus x. Negative 1 minus 5 is negative 6 equals 0. Alright. So there you have that. Then you could use the quadratic formula. You could use completing the square. Can you use factorization? I want to use factorization, but can it work? Let's see. If I use factorization, it would be x squared at one end minus 6 at the other. Using the AC method, A is 1, C is negative 6, so AC would be negative 6. I need to think of two numbers that multiply to give negative 6 and add to give negative 1 to get the negative 1x. What do those two numbers be? 2 and negative 3. 2 times negative 3 will give negative 6. 2 plus negative 3 is negative 1. Okay, right. So far it seems that factorization could work. Alright? Factorization could work. So here now, you could have plus 2x minus 3x, or you could have minus 3x plus 2x. It doesn't matter. You get the same answer anyway. Remember, with factorization, you factorize these two and then these two. You're going to get two brackets with the same things in them. It's x outside the bracket, x plus 2. Remember, if you don't remember the methods and so on that I'm using here, just make a note in the comment section and I'll go through it again. I could redo this question in more detail to remind you exactly how everything works, right? But I'm not showing all the steps while I'm working here. Minus 3, open bracket, x plus 2 is what you would get here. Now you have these two as a common factor, the x plus 2, so you put x plus 2 outside a bracket. This is my new bracket. Inside the new bracket, x plus 2 into x, x plus 2 goes x. X plus 2 into negative 3, x plus 2 goes minus 3. So there you have it. X plus 2, x minus 3. Right? And remember, they give 4 marks, so it prepares you for a lot of work to get those 4 marks. Alright, so here, x plus 2 multiply x minus 3 to give 0. It means that either x plus 2 equals 0 or x minus 3 equals 0, or both would be 0. If x plus 2 is 0, then x is equal to negative 2. And if x minus 3 is 0, then x is equal to 3. Alright? Those are just the values of x that you have. Now, you'd have heard a very loud bike passing a while ago. The kind of lawlessness, indiscipline, and lack of reinforcement of the Noise Abatement Act results in that sort of thing. Because I'm in a residential area. That should be a quiet area. But anyway, continue. You have values of x. You need to find the values of y. Let's use the linear equation, 5 minus x. And let's rewrite it as y is equal to 5 minus x. When x is negative 2, then y is 5 minus negative 2, which is what? 5 plus 2 is 7. When x is equal to 3, y is equal to 5 minus 3, which is 2. What the question asks you for are the coordinates of the point M and N. M One of them, they didn't say which point was m, which point was n. So let's say when x is -2 and y is 7 is our m. We have m at at -2, 7. And n is the other point at 3, 2. So those are the coordinates, alright? Those are the coordinates. 4 marks there. Oh, part C. We have part C to deal with. Part C deals with a graph. It looks like a velocity time graph. So let's look at part C in another video.